Okay, it's now recording. Okay, hi everyone. This is the speaker will be Dr. Gilad Feldman from Department of Psychology with the University of Hong Kong. He'll be speaking now.
Yes, thank you. Glad to talk to you. Hope to have a chance to do this in person one day soon. Today I'll be talking about generally what we do with this team called the core team that talks about collaborative open science, how I do this, where this came about, and what is it that we've achieved so far, and what's ahead for us. So the general title is like linking education, research, and community to promote things like open science. So everything that I try and do, both my courses and all the talks are on YouTube. So hopefully this one as well. Afterwards, you're welcome to go have a look at the rest. All of my teaching materials, everything that I've ever done is also on the open science framework. So if you need any slides about social psychology, decision-making, and open science, you're welcome to it. I'll start with the obvious. We're facing a lot of challenges. Climate change just came out of a pandemic. So we do need credible, optimized science. And the question is, where are we when it comes to science? And I think the most recent one that perhaps you've heard of just came out like a year or two ago is cancer biology. I'll just very briefly go through this because I assume that a lot of people are familiar with this, but not in psychology, but in what's called the hard science or an exact science, things more related to biology and medicine. They looked at all things related to cancer. So a very impressive project. Hopefully, they were hoping to look at 193 experiments, but at the end, they only were able to start with something like 50. And out of that, the general conclusion is 18 were completed, and only half of the 18 were what was considered to be a partial or full replication. So where does this leave us in terms of replicability? If you look here on the left, original findings versus the replications, you can see it doesn't look very good. And the bottom line table that I look at, original positive results, how many of them were replicated in terms of papers, experiments, effects, and so forth. Depending how you look at this, it's somewhere between 11.6% to 18%. But you can also be more pessimistic if you look at the beginning of 193 hopeful experiments to replicate. So this doesn't look very good. I go around talking about these things. Some people don't think that this is a big issue. For me, this is a very big issue, and I care about this a lot. Those kinds of different things that we've been doing in the past decade or so, looking at replicability also in the exact sciences. So perhaps you're familiar with this. Doesn't look very good. In social psychology, let's look at my field. We've been doing open science collaborations in many labs, and you can see Brian Osick from the Center of Open Science trying to summarize this whole thing. Won't go into this in detail, but my general summary of social psychology is that we're somewhere in between 30 and 50%. And in the things that work, the effect size seems to be about half of what was originally published. When I go and I talk about this with other fields, they seem to think that perhaps this is psychology or social psychology. It definitely doesn't seem like this is the case. Cancer biology was the latest. You can see all these headlines from the different domains and the different fields. We need to go back and look at everything, not just psychology, to see what is credible, especially given that we're just out of a pandemic and facing all kinds of challenges. So sometimes I have some debates with people about what is the status of science. I think in general, it's always good for us to self-reflect and reassess and try to improve on things. So the first time that I sat with myself thinking about this is when I did my postdoc. I was at Maastricht University in the Netherlands, and I had a year where I really sat down to think, what do I want my career to look like? And finally, my perspective is a little bit like these cartoons over here. Sometimes people, when we talk about climate change, we talk about things like livable cities and green jobs and clean air and water and healthy children. And then some people push back on this and say, but what if all this is a big hoax and we create a better world for nothing? This is how I look at open science and trying to improve. We're talking about all sorts of things like decreasing bias and sharing more and making use of this and making a faster process, more collaborative research, open access to everybody. And somebody says, but what if there's no crisis and we create a better science for nothing? So let's just focus on creating a better science. How to do this? Endorsing and promoting open science. I'm not the only person who's talking about this. So 2 years ago, UNESCO came out with this declaration. So now people come to me asking how to do open science rather than me having to promote open science to them and convince them that this is needed. Not only this, but it seems like even when the G7 come together and try to discuss the most urgent issues in the world, they also talk about science and technology and then talk about things like the FAIR principles. So this is urgent. So this is what I came up with in 2016 about the way that I want to do my research. So I want to focus on trustworthiness and reproducibility, replicability, and inclusion, equity. So all these are very important. I had to take everything that I was doing up until 2017, including my PhD work, and put this aside for a few years as I try to make sense of things. And although I'm used to just working on my own, maybe with an advisor, and doing things in a certain way based on my PhD training, I forced myself to really look around, see what's available, and put down in bullet points, what is it that I want, what kind of skills I want to gain, what kind of science I would like to take part in. So I think the easiest of those is full transparency. So everything that I do, from the ideas up to the publication, is full transparency. If you're active on Twitter or Blue Sky, you can follow me and see that every step of the way I communicate as broadly as possible. I share preprints, I share everything that my students and I and my collaborators are doing. And then increasingly trying to move to, now it's more common, but back then, 2017, doing pre-registrations or a registered report was difficult. What is exactly a effect size, how to do a power analysis? Now it's more taken for granted, but back then it seemed like almost an impossible undertaking, especially for a postdoc with no support from the environment. But I think the thing that I realized that I really needed is a community. I cannot do this on my own. So sometimes the Twitter sphere gives me a community. Sometimes it's SIPS, the Society for Improvement of Psychological Science, has a great conference, and people are very active over there. Most recently, you have things like Fort. So it's lovely to have people who care about the same kind of things, and you can collaborate with those. But I was also trying to find an alternative model, and this is what I'll share with you. What other ways are there in order to create a community if you don't have this? And that's what I've been doing in the last 7 years or so. So as I became, from a postdoc, an assistant professor, I try to see how I can leverage what it is that I do, the curriculum that has been assigned to me, the education system around me, mostly conservative place, the University of Hong Kong, that does things in a very traditional way. How can I revamp things in order to combine education, research, and community to pursue some of these goals? So this is the traditional teaching. This is unfortunately how I was trained. So there's this, usually a white male professor standing in front of a classroom, a tenured professor, saying, you must listen to me. I am the professor, therefore follow my truth. And my truth is this, based on literature, based on personal experiences. And then students are just like sitting in the background, being very passive. Maybe they take this, maybe they don't, memorize this, dump this into an exam, and then forget all about it. But I was looking for something different. And increasingly, I saw more and more models of some people who are suggesting that we should do education in a different way. And I really like this book that came out with Adam Grant, Think Again, a few years back during the pandemic. And this chapter, especially rewriting the textbook, is rather than teaching students knowledge that could be flawed or could be biased or could be limited, nowadays people have access to education that goes far beyond my specific knowledge, my personal knowledge that I've gained. So what I can do is I can use the classroom in order to teach students how to acquire knowledge, how to think about knowledge, how to work together with others in order to improve our knowledge. And for that, we need to adopt a scientist mindset with a lot of humility to understand that even established professors make mistakes and we can all work together. I can learn from my students. Rather than sitting passively in the background, students can take an active role and actually engage in science and contribute to the community. Another thing is that all of our textbooks are just too straightforward and clean. It doesn't seem like there's messiness, and you want straightforward answers, even if they're flawed, even if they're inaccurate. And I think confusion is generally natural. Uncertainty is natural, and we need to teach this to our students so that they understand the complexity of the universe and what science really is. And most importantly, is that students can inform science. We can work together with them. So instead of this traditional model, I adopted something more from the Maastricht University mindset about problem-based learning, but collaborative learning. So I assigned problems to my students. In this case, it's doing replications of classics in my field, social psychology, judgment, decision-making, and I guide them. I give them resources. I tell them where to look. I don't tell them how to do this or what the expected outcome is. So there's a lot of uncertainty and messiness in the process, but at the end, all of us gain. They gain how to think about things, how to pursue information, how to integrate information, and then the community I can benefit from them asking new questions or approaching this in a different way. So that's what I decided to do coming into University of Hong Kong. And it's amazing that they let me do this, because in many universities, you have to go through a lot of processes in order to approve all sorts of things. But basically, I took all of the textbooks, I put them aside, and then I said, together with you students, I am going to check what works in social psychology, judgment, decision-making. Let's do everything together in the classrooms. We make predictions, we run this on ourselves, and then we see whether this went as expected or not, and then we try and do this again to inform both us and the community. So student-led, doing actual science, looking at real impact, going through the entire scientific process, including peer review. So students work in different teams, and then they peer review each other, and then they get a peer review from teaching assistants and from me and from the Twitter community, people coming in and looking at the Google Docs and really applying the latest best practices, tools in psychological science, pre-registrations, power analysis, reproducible code, and so forth. Complete transparency, all the principles of open science, trying to live to the highest standards so that they can see, even if the current literature is lacking, that there's a different way to do this. So I'm trying to combine collaborative research, open science, meta science with my teaching. I'll give you some examples of things that came out of this collaboration of this team. First, I do things with my students in the classrooms and with my teaching assistants. We try to set up everything collaboratively. So everything is on Google Docs, and we all aim together to write up replications, and at the beginning, the first 2 years, also run these replications and do data analysis. But as we're doing this process, we're also reflecting on the process. So for every little thing, I have a guide, and this guide, rather than me writing by myself, what is it that I expect, I made this into a Google Doc where everybody can come in and contribute to this. So I'll give you just one example. Where was this? Yeah, so this is one example of something that came out of this. It's the effect size confidence interval. So students are not familiar with this. Maybe at the beginning they ran a t-test, saw some p-value when they came to the classes, but shifting into an effect size confidence interval mindset requires a little bit more than that. So I honestly did not really know how to communicate these things. I did some meta-analysis. I knew what effect sizes were, but how to allow them to pursue this, understand this, write the right code in order to see what effect sizes and confidence and intervals are. So we started with a very simple guide. It was 2 pages, and now we have a group of international experts about effect sizes, confidence intervals that came together and came out with this preprint. So this model that we have is that you can see here all my students, about 400 almost over the years that went through my courses since 2018. And then I also have thesis students. So every year it's between 5 and 10, 7 something on average. And once the students finish this, and I'll show you exactly what that looks like, then I invite people on Twitter from all over the world. We have around a fourth of this are from the UK. I guess they're in the UK, things are happening more in open science, and there's lots of eager PhD students. So a lot of early career researchers from around the world see what I do in Twitter, what I share about my work with my students, and then they come in and they take the lead on some of these projects. So after 5 years, how many of those have we done? We've done more than 120 of these replications. Many of them are with data collection that was collected in my courses. And most recently, in the last 2-3 years, it's mainly registered reports, stage 1. So in the classrooms, we write together things without data, but based on simulated data. So I just simulate data for them with the Qualtrics, and then they analyze that simulated data, and then we submit that to the journal. We have over 20 collaborative open guides that you can also join in and contribute to that. And everybody who contributes, if it's something meaningful, then you become a co-author. And then I'll talk a little bit at the end on things regarding research assessments. So not active for very long. The first things that came out like 2019, 2020. So getting into the pandemic year, which was difficult. But you can see increasing impact slowly. So it has like its own Google Scholar for this team. And by now, after 4 or 5 years, we have quite a bit of impact, and it's growing all the time. So talking about community resources, you can see a partial list of all these resources. So we have a guide for everything, how to do R Markdown, power analysis, statistical methods, Jamovi, JASP, whatever it is that you use. So for any one of those, you're welcome to join in and become a co-author. In terms of replications and extensions, which is the heart of what the core team does, first, a word about why do replications at all? Why is this good for students? Why pursue that and not just let students do whatever it is that they want? So students are a little bit clueless, especially when they're undergraduates, second year, fourth year. They have this general biased idea from the literature about what is valuable, what is a contribution. But I think replications just make everything a lot easier, straightforward. And there are lots of benefits to replications. So I think the most obvious ones that we tend to think about when we think about replications about verification. So you reanalyze all the reported statistics, and sometimes you can catch mistakes or find fraud. And we have, and I'll give you an example for that. Reproducibility, whether really you can reproduce things even as early, going back to the 1970s, Kahneman and Tversky, and all that work that was very briefly detailed in their reports. So to reconstruct all the materials, to understand what it is that they actually ran, lots of value in this. And then, of course, if you just repeat something, do you get the same kind of findings? Does it go in the same direction? Is there a signal? What are the differences in the effect size? But I think the things that replications don't get enough credit for are things that related to theory and methods and generalizability. So we have quite a few examples about how we were able to inform theory. So sometimes you can check whether the target article has good alignment with the theory. You can design extensions in order to improve on the testing of the theory, and you can get to some interesting insights that were not originally there. And we have countless examples of ways that we moved theory forward. We also look at things like related to measurement. Was the measurement correct? Sometimes we have extensions that improve on the measurements in a between subject design in different conditions. So lots of ways to address this and improve on what was done in early work. And then generalizability, we have different teams around the world. The most prolific and active of those is the Brazilian team that takes what it is that we've done, translates this to Portuguese, and runs this with a Brazilian sample. So replications are not done very often. You can see the ratio in psychology, it's 0.2, so only 1 in 50 of the articles is being replicated. And this is a real problem. And I think I like this general rule of thumb that came out in 2012. When we see how low the ratio is, the rate here was 1.07%. I think an arbitrary selection, if a publication is cited more than 100 times, it would be strange if there's no attempt at a replication. So we revisit a lot of the classic articles that have more than 100 citations to them, and many of them have never received a direct replication before, some of them not even a conceptual replication. So it's just been cited hundreds of times without people ever taking the time to see if it really was done well, and whether the findings really repeat. And you can find the same things. As early career researchers, as students, there's also lots of benefits in terms of reducing risk, higher credibility. There's less effort because you're building on other people's work, and there's lower costs. It's more systematic, and hopefully helps with value and impact, because the things that you focus on, you already know that the community cares about. But I think for most students, novel work is really risky, and also does not allow you to learn much. If you do replications and extensions, you can maximize learning. So by students doing this in the classrooms, you can really gain a lot of insights. If both of the things fail, then you know that your foundations are not solid. If the replication succeeds, but the extensions, the novel stuff, doesn't work, then at least you know that the foundations are solid, but then you need to rethink what it is that you're doing. If both succeed, hooray, everything is great and you've advanced the literature. But sometimes the original fails, but what you've done, the extensions that you did, the improvements in measurement and theory, that works. And then we can rethink and inform our understanding of the literature. So all this is nice and good, trying different things with early career researchers and students in the classroom. So it seems like a nice education initiative. In the beginning, when I came to the university and trying to implement all of this, a lot of people were skeptical of this ever having an impact beyond the classroom. But a lot of people are also very skeptical of what undergraduates can actually do in a one-semester course, second year, fourth year. So I didn't really know in 2018 how this is going to play out. But my answer to all these questions about whether students and early career researchers can do high quality work is definitely yes. And we have proof for this. You can see we started publishing 2019, 2020. 2021 was the first big year when a lot of things came out. So you can see this is how we work together. All the underlined names over here, the Chinese, Cantonese, Mandarin names, are undergraduate students from my courses. The first ones that are at the beginning are early career researchers. Could be somebody like you that come in, take the lead, verify what it is that the students did. And then you can see they have this star asterisk to denote shared authorship, and then followed by the teaching assistants in my courses, and then me trailing at the end. So when we have all these early career researchers working with my students based on what was done in my courses, then we can really increase impact. So rather than me doing 1 or 2 replications a year, now we can really work power of community collaboration and education. 2022, 8 more, 2023, 10 more. So it keeps on going. And I think the better we get at this, the higher the quality, the higher the impact. So this was all really nice. I was seeing that I stopped doing that. I'll tell you a little bit what I have been doing in the last year or two, moving away from replications in the classroom. But this was like a good proof of concept of what we can do with students. But I was looking for a way to do this even better with guided thesis students. Is there a way of improving on this? So in my classes, in one semester, first they design the replications and extensions. Then in the middle of the semester, I lose some sleep, and then I conduct all of these data collections. And then the second part of the semester, they analyze this and they write the manuscript. But I was looking for something that would increase credibility, endorse open science even further, and also something that I can do with my thesis students that would increase the level of their work. So I'll just very briefly say something about the traditional publishing model, which I think is really broken. There's so many problems with the way that we do publishing, the peer review, and everything else. But you can see that from your own experience, our own experience in the PhD for me, suffering through this, is that first you have an idea, then you collect the data, then you write it up, everything is completed, and only then you send this to the journal. And then so many problems with this, because you have outcome bias, hindsight bias. If it's, for example, a replication, it's if successful, so what? We knew this all along. If it's failed, maybe something is wrong with the replicators or the replication. None of this seems surprising or interesting. So many outcome-related heuristics and biases that decrease the value of the work, not to mention that you have different camps. So if you get reviewers from a different camp, they will reject you. If the journal doesn't see a positive, exciting novel finding, that they reject you. So all these things are because we already share the results. But the most important of all of those is that once you've collected the data and written everything, getting all that feedback about, let's say, a broken methodology or misalignment with theory, it's too late. The only thing that you can do is collect data again. So much waste, so much heartbreak in this process. And this is, for me, has been a struggle with academia all along. Then when I saw registered reports, I was just blown away by how much better this is. When I talk to students and I present to them the two different models, they don't understand why registered reports is not the way in which we do science. How does that work? You develop the idea, you design the study, but you don't collect the data yet. You send that to peer review, and the peer review can help you check whether you've done things well, whether the methodology is okay. So many times we've got registered reports peer reviewers that helped us find mistakes, helped us improve, helped us do better. And once everybody reaches an agreement, then the journal gives you an in-principle acceptance, which means it doesn't matter what the outcome is, it's going to get published. And then in the second round, the only thing that the reviewers need to do is see whether you followed your pre-registration plan. Or if you deviated, then it's okay to deviate, that you've justified this and that it seems reasonable and the conclusions are warranted. So most of our stage 2 have been a breeze because we've just have the pre-registration, we've shown what the actual data is with discussion, and we can show the comparison between these two. And then the reviewers are like, yeah, we already went through this, we already approved this, so they did everything well, let's just publish this. So many times the stage 2 for us, it's like like one round and a few weeks just to approve this. So from all these problems in the traditional models about all sorts of questionable research practices and harking and publication bias and all of that, in registered reports, you really don't have any of these things. So for me, I really wanted to endorse this, but some problems. And I understand people who are hesitant to do registered reports, especially as students, as thesis students, PhD students. And if I want to embed this in my class, then it takes a lot of time because you need to do everything in advance. There's lots of back and forth about how to align the expectations of everybody and to get to the right methodology. So this was a good initial idea, but some things were still lacking for me to be able to implement this with our team. Luckily, 2-3 years ago, came out this wonderful initiative. To me, this is a revolution in science. Once I started to do this, I did not look back. Everything that we do, we submit now as peer community in registered reports. There's so many benefits, but I'll just name a few that to me are just like mind-blowing. So peer community in registered reports, if you do a scheduled review track, guarantees peer review within 2 weeks. They have this magic thing where you submit a snapshot, which is a one-page alignment of research question, hypothesis, the methodology. This is just meant in order to communicate for them to be able to find reviewers. You submit this 6 weeks before you want your review to happen. And then they take your snapshot and look for reviewers saying, within 6 weeks, can you please find 1 week to review this? And we work for 6 weeks on our project. And then everybody aligns to the same schedule. And once we submit, reviewers review this within 1 week. And then the editor takes another few days to a week. So within 2 weeks, you get peer review. Unbelievable. I can't understand why this has never been done before. In addition, another revolution. So rather than you submit to one journal, reject, okay, another journal, reject, okay, another journal, reject, what you can do here is that you can work together with the community. The community recommends your stage 1 or endorses your stage 2. And then automatically you can choose which of the journals you want to publish with that are affiliated with this peer community. So for example, in my field, psychology, Collaborate Psychology automatically will publish anything endorsed by the community. In social psychology, we also have other things like International Review of Social Psychology. So this list of journals is already quite impressive, but it is growing over time. And then you can decide, it's power to you as the author, where you want to go with this. And another great benefit is that all of the peer review is open, identifiable, and citable. So everybody gets credit. All the peer reviewers get credit. Everybody is working together. There's no reason for hostility or biases because this is a registered report. Everybody is working together towards a plan. But I think this is especially important because then I can look at what others have done in other peer community and registered reports and learn from that in order to do my submissions. So unbelievable, changed everything about the way that I think about science and the way that I want to do science, and really pushed me in order to live to a higher standards, uphold higher standards of open science. In addition, once you have registered reports, it's much easier to convince your university to give you funding. So I told them, to the university, if I show you an in-principle guaranteed publication by an undergraduate student to this community, to all these 30 journals, will you fund the data collection? And they said, yes, here's $1,000 for 30 students for you to pursue this. There's no risk involved because they already know that this is going to be published. So $1,000 is a very small price to pay for a guaranteed publication. And everybody wins. The university wins, the student wins, the community wins. So you can take what it is that I've initiated. It's called the Registered Reports Challenge. I'm trying to do this in UCL. Or in the UK somewhere, a good way for getting funding to your project as a student, as an early career. So this is what I do with my students. All the thesis students submit in the 1 year that they need to do a thesis. So undergraduates and masters, taught masters, all of them submit their thesis as a peer community in registered reports to get expert feedback from the community, and all of them are published at the end as a journal article. So here's, for example, we started doing this like 2 years ago. Here are the ones that are already published with the journal. So you can see Collaborate Psychology is the one that gave us the most, but also International Review of Social Psychology. And you can see the stage 2 recommendation by the community is open. The stage 1 is open. Everything that we've done in the process is open. And the team altogether, all the thesis students working with me, there's already 15 that have received stage 1 in principle acceptance. So that means that this is a guaranteed publication. The students can already put this on their CV. And all that's needed now is to complete the stage 2 peer review. Very fast process. So in the upcoming year, hopefully these 15 will be finished and published as well. And we have more pending. So undergraduate students, how did they do this? If you want to see this, you're welcome to click on the links. But generally, this is what peer community looks like. So Chris Chambers, the one who promoted registered reports, was our recommender many times. Perhaps you're familiar with Roger, a big person in open science who was the editor of Journal of Experimental Social Psychology. You can see the recommendation by Chris Chambers saying, this is what they've done. This is why I endorse this stage 1. And these are the journals where you can publish this. So this was one of our first ones. Now you have a lot more to choose from, but you can also see the review by Roger and the decision by Chris and how we replied to everything with track changes. So no longer do you have to guess regarding a publication. What happened there? Is the COVID vaccine solid, not solid? Was it peer reviewed? How was it peer reviewed? Is there any bias there? Everything in peer review is open, identified, and shared. To summarize everything that we've done in core team, this is a little bit outdated. We're working on the update because we have so many replications, but the first 80 that we've completed of the judgment and decision-making literature, it seems like at least for the judgment decision-making classics in the literature, all this Kahneman and Tversky, with other stuff, our replication rate seems to be a little bit higher than what was originally in social psychology, definitely higher than cancer biology. But we do have some mixed, inconclusive, and unsuccessful. The reason why I want to show you this is because sometimes people are skeptical whether undergraduates can really do good work. Of course, you can go and just have a look at their work in order to assess their work. But I already want to show you that we've been able to replicate well classics in the field, sometimes mixed inconclusive. So we were able to get additional insights. And even in the things that were unsuccessful, the undergraduates identified a lot of issues and ways to move forward. So I think this is a big achievement for the students in my classes and the thesis students that are working with me. We also do assessments. Okay, so I need to wrap up. So assessments, I'll just go over this very briefly. Every year we do assessments. In the last 3-4 years, we always do assessments of the previous publications. So it's not only that we've done a preprint, but we also ask the new students, before they do their own replications, to do assessments of replications in previous years. And it's really working because they find mistakes. So for example, perhaps you're familiar with some of the issues recently with Ariely and Gino and all of that. We got into the whole mix with this because we identified some errors with one of the articles by Dan Ariely. And you can see in Retraction Watch, a team of students in University of Hong Kong out of nowhere identified some issues which led to an expression of concern by Psychological Science and Dan Ariely. I also pay students to find errors in my work. So I have this pledge called Check Me, Replicate Me, corrections and replications of my work. So if you find an error, not only do you get a better grade for the assessment if you do an assessment well, but if you catch an error and you help us improve, you also get paid for this, or you can decide to donate this. And if you donate this to something like GiveWell, then I match it. And you can see, for example, 2 years ago, all these teams find minor mistakes with one major mistake. And we caught this just in time for our revise and resubmit to make the publication better. So you don't have to take my word for it. You can go and see, because I share all my evaluations publicly. So you can see what students actually feel about this. So you can see at the beginning, there's some negative stuff, unnecessarily intense, very confusing, overwhelming workload. But you can also see the good in there. And I think this is really a testament to how much they're learning. So I really like this comment, one of the most revolutionary miracles in HKU psychology. Students can make a difference, opportunity to get a taste of a real scientific research. And you can go and listen to talks by my students. So undergraduate student had 2 publications with us. Master students had 1 publication with us. Also, the early career researchers that are working with this, we have a column at Psychology Today, so you can go and read this. Max here also gave a talk. So if you want to know more, not from my perspective, but from the perspective of early career researchers and students, then you have a lot of resources and talks and columns available. So lots of options for you at UCL. You can take everything that we've done in my courses, all the teaching materials, and implement this in your own classes. You can also take our, like the Brazilians did, take our stuff and run this in the UK, translate this to a different language. If, let's say, you're a man in China or wherever you're from, where you feel that you have another language, tell me whatever it is that you need from me in order to, for me to help you to do this in UCL or wherever you're at. We're very happy to collaborate. So we support the Brazilian teams and other teams around the world to do these kinds of things. If you want to join us, this is the link, how to join, all sorts of things that you can do, ways to collaborate and ways for us to work together. I'm going to skip this because we're a little bit out of time, but I just want to say that in the last 2 years, I've also implemented this model in not just doing open science and replications, but also trying to do effective altruism, doing more good and doing good better. So for example, here, 3 collaborative books that the students wrote about effective altruism, how to evaluate charities, how to evaluate doing good, morality, and also designing charities and building charities in order to do some more good in the world. So we're running some giving games, we're doing all sorts of things. So this is overall the summary of everything that we try to do in the classes at HKU together with the community early career researchers, collaborating together, working on open science, meta science, and implementing replications, assessments, and building community resources. So everything that I mentioned, I know it was very fast and very brief, but all of that is open for you to look at and see if you want to implement this and whether you want to work with us or implement, build on this further. So we have a mailing list. Every 2-3 months, I give an update about all our activities. So you're welcome to sign up. You also can always contact me directly to let me know if there's something that I can help with. Some early career researchers and students are a bit scared of professors, so please don't be. Even if I'm busy, I'll connect you with some of the other early career researchers. And together, hopefully, University of Hong Kong, the international team, and UCL and UK, we can do some good together and promote open meta science together. So that's it for me. Thank you.
I loved your talk. I probably will have to look at your slides again. There was a lot of interesting material covered and lots of ideas that I will try to incorporate in my teachings. Now, regarding replicability and extensions, that really caught my interest because I lead a module in statistics for undergraduate students, and I'm also a supervisor for dissertations at undergraduate and postgraduate students. And I was thinking that we don't cover enough replicability, and it could really be a great starting point for a dissertation that could then be go on to be published. I'm just thinking that for our undergraduate dissertation students, they start working on their topic in late October, beginning of November, I'd say. They have to submit in early May. So we only see them for like 6 months. They have 6 months to work on their project. So in terms of replicability, I'm thinking, is it really feasible from your experience to have undergraduate students complete replicate a study to a good standard in 6 months? And also a follow-up question on that, what you do with hard to reach populations? Like if you want to replicate a study that was done on children, prisoners, patients suffering from mental ill health, do you use synthetic data? Do you have other approaches? So I'd like to hear your opinion about that, if possible.
Yeah, good. Very good questions. And it helps me clarify some of the things that I went over very briefly, very fast. So yes, your model is exactly the same that we do at University of Hong Kong. It's traditionally British, so they have the British system. So exactly the same. They start working about November, December, and then they need to submit the thesis by April 15. So this is a very tight schedule. How do we do this? With a scheduled path in peer community and registered report. In the middle of November, we write the 1-page snapshot targeting the peer review for the end of January. So we submit we work together. So we use all of the time in December, January in order to finish these projects. And I'll talk a little bit about complexity and timeline. It's tight, but it's doable because we have a lot of resources. We have templates. They have other examples. They've seen other people do this. And it's a very structured process that reduces the risk and uncertainty. Then peer review, 2 weeks. Guaranteed comes. So middle of February, you already have a peer review. It takes about 2-3 weeks to revise, depending on how long these things are. And most times, not always, but most times it's only one round of peer review. So the recommender, the editor, says, if you implement 1, 2, 3, 4, and you've done this well, then I will accept this, endorse this as a stage 1 for you to proceed. And many times there's no debate. Everything is very straightforward. So we're able to do this effectively. And then the editor goes over this, takes another 2 days, 3 days for them to go over this and say, okay, endorsed. And this is, we're just doing this now. So we started doing the data collection. I conduct all of the replications are on social psychology, judgment decision-making classics, that I can run online. So I run this with Amazon Mechanical Turk, used to be, on Cloud Research or Prolific. We're shifting more towards Cloud Research Connect and Prolific, moving away from MTurk, but still everything is online with Qualtrics. And then data collection, I just completed one yesterday. It took an hour and a half, so very, very fast with a sample of something like 1,000. And then I give the data sets. And because they've already done everything with randomized simulated data sets, then all of the code is already there. When they get the data set, they just plug it in and all the results are so the results section is like written. And then all that's left is to add the discussion, maybe a few minor changes in order to adjust the introduction. But then stage 2 can be very brief. And actually, you don't need to go through the stage 2 in order for them to submit their thesis. So they write up, send their thesis to the general office. And then in the same time, we're also submitting this to peer review. And stage 2 is typically like very fast. Like within 1 month, typically we get some decision on that. So you can see I've done this successfully for over 2 years, and I think we're ahead of schedule for this year. So from middle of November until middle of April, you can complete this with undergraduate students, masters taught. About how to do the more complex stuff. I'm very lucky because judgment decision-making, it's a strategic decision. I was not a judgment decision-making scholar in 2017, but first of all, I wanted to focus on things that I think are solid. So whenever I ran heuristics and biases in my courses in Israel, Netherlands, US, Taiwan, Hong Kong, I was able to see large effects in the classrooms and demonstrate this rather easily. And I would say that generally, we also have like the data for replicability rate, easier to reproduce and replicate with high replicability rate. More harder to reach populations is tricky. I would save this for like MPhil and PhD. So you could do that. And actually, registered report model is very efficient for that because you focus on the best plan that you want to get done without thinking too much about what are the costs or what happens in the second stage. So for example, many in my department are neuroscientists or do developmental, so babies, and putting people in a scanner are very time consuming, very expensive. And sometimes students have a sample, I don't know, 20, 30, and then so what I recommend to all these students is you do the best stage 1 that you can, and then go on Twitter and say, I have an in-principle acceptance, stage 1 in-principle acceptance. Who wants to work with me? And then people who have labs and have the resources, but don't have, I don't know, the big ideas or did not go to the registered report, that's how we work together as a community. So everybody can come together. So I've seen a lot of these models. We have more and more of that in our department. So if you have hard to reach populations or something that's very costly or even time intensive, you can find other collaborators around the world once you have an in-principle acceptance, because there's no more risk. Everybody knows that if they're joining, it's going to be a publication. Psychological Science Accelerator works this way, of course, on a much larger scale. So you have many of these collaborations. But I would say, at least at the beginning, if you're thinking of doing something in UCL, start small and simple. Don't go with the hard to reach populations. Start with things that you can run online, the similar model. Once this works, increase complexity. Every semester we're making this bigger, harder, more complex. So learn by starting small and then increasing step by step.
Perfect. Thank you very much.
What Stephen has asked was one of the things I was going to ask as far as timelines. But also, my question, I guess, is about how you choose which studies you're going to replicate. Like, do you go to the students with, here's 50 students studies, choose one, or do you expect them to choose? And so forgive me if I missed that, but I'm just interested because there's so much out there, and our students, obviously, they want to come in and do one study and save the world. And so how do you manage that, or help them manage it, perhaps?
Excellent. I did not touch on this, and this is a very important point. And I think this is critical for the success of this, for this to work well. Now, I'll start with the thesis students because I think this is the most relevant. I want them to have choice, but I also want everything to be practical and doable, and that to know that I can finish this within the given timeline. So I maintain a list. So every time I see an article and I look at the methodology and I think to myself, okay, we can do a fairly straightforward Qualtrics. We can run all these experiments and do something interesting. The effect sizes seem rather big enough for us to be able to detect this well. And it seems to be an influential classic in the literature. So I have this very basic criteria, and actually a lot of studies fall under this criteria. And then I maintain this list. You can actually see this list on my website. And from that, I allow the students to choose whatever they're into. And it covers everything from, basic heuristics and biases to morality or stigma or misinformation. So there's a lot of topics that they can choose from. Sometimes I also allow thesis students to come to me with an article, and then I make an assessment. But typically, many times they are overthinking this, or they're influenced by things. They want to do something bigger than what it is that I think that they're capable of, or what it is that I know from experience. And then usually I have at least one or two articles that are similar to that, but are kind of more simplifying. So I think the way to start with this is to have a list. With thesis students, allow some kind of choice from that list. With courses, I suggest, especially if you're running this in the first semester, to start from the most simple classics in the literature. So I don't know if you're familiar with all the Kahneman, Tversky stuff, but it's basically a vignette and a choice. A or B. This is like the most, and once you get that done well, and I think at the beginning you should assign those. So this is the article, this is the article, this is the vignette, this is the vignette. Once you get that done, you can increase complexity and offer a little bit more choice to that. Thesis students care about choice. The course students don't seem to care too much about that, as long as it's interesting and it's relevant to what the course is about. So in advanced social psychology, let's say if it's morality, then we try to look at classics that have like a funky effect, something that's really interesting. That whatever it is that we find, if it's successful or if it's failed, it's always interesting to see what happened at the end. So I would focus on choosing those.
Thank you. It makes a lot of sense.
Can I ask one more question? I think we have time. Yeah. You mentioned that now every student of yours, like MPhil, or they all submit to peer community. I just wonder what the success rate, like just completion rate. Do everyone follow that schedule and is able to do that, or like only the best students can do that?
Yeah, it's good question. I think it's difficult to learn from one university to another. And I am very lucky because I am based in what's considered to be like an Asian Ivy League. So like top of we get the best of the best, like we really pick. So already they come, I've never seen students as motivated and as capable as the ones that I've been in other places in the world. I am very privileged in that. However, it doesn't work for everybody. And what's challenging about the University of Hong Kong students is that sometimes they have a little bit more challenges with changing traditional models. And then what is really important is to align expectations. So you actually can go on my website and you can see my lab guide on everything that I request thesis students that are working with me to write to me. And this requires them endorsing open science and understanding what the peer community is. It's almost a little bit like signing an agreement between them and me. So it's not for everybody. Of all the students, there's a very small subset of students that want to work with me on this. So I select of the already high quality students that we have at University of Hong Kong, I already select people that have the right kind of mindset and are motivated to do this. And once they're in, we have, I would say, until now, all of the students completed their thesis in this way, with one exception of a student. But this is like a story about the original authors as peer reviewers and peer community. So they completed the thesis, but it's been a little bit more challenging with peer community because of pushback from original authors. But generally, I would say, not just with students, but in my work overall, we used to have a rejection rate from journals of about 70%, 80%. Once we moved to registered reports, what is the rejection rate for my work? It's been zero. I have zero rejection rates from journals because we moved to register. There's no reason to reject you because everybody can work together on getting the right plan. So since we started submitting to peer community, also with the students, the acceptance, the stage 1 in principle acceptance rate is 100%. Of the students, aside from one student who didn't finish for technical reasons with the original authors, everybody completed things successfully, and I expect that all of them will get to stage 2 acceptance. I'm not sure that these are the rates that you can expect everywhere, but I think if you adopt a similar model, I would guess that regardless of where you run this, you will have more than 50, hopefully more than 70% of people finishing. But what is the most important is that regardless, they will get good feedback from the community. They will be able to achieve much higher standards of a thesis submission, adhering to the best practices of open science. So not for everybody. First selection in aligning expectations, and then just making sure that the process is articulated, clear, and that they're able to know in advance what it is that they're walking into.
Yeah, I've been thinking that just throughout the process that you describe, is there any way we can say dumb down certain processes, even if they don't follow through, they can still learn a lot from that, or they might not have to choose something that's like groundbreaking, makes it into the best journal, but maybe everyone can just benefit from this model.
Yeah, another thing that you can do is what I do in my courses. So we don't submit to peer community in the course, but first the students finish writing everything up. They get the peer review from me, from the teaching assistant, from the community, and then we finish a manuscript, and then I put the manuscript on my website somewhere public, and then I go to the Twitter sphere and I invite early career researchers who wants to work with us, and then early career researchers take this, verify this, add some stuff to it, and then I work with the early career researchers in order to submit this to the journals. So they don't necessarily have to bring this to publication within the 1 semester or 1 year, but at least it should be high quality enough for this to be interesting for somebody to come in, take the lead, and help the PI bring this to publication.